In this video, we will demonstrate features of the CPR tool related to anonymizing threat intelligence data. We will use a test event that includes sensitive information such as passport numbers, IP addresses, and email addresses. We begin by reviewing the environment file for TINTED, the threat intelligence module of the CPR tool. The parameters related to anonymization are displayed here. The event source anonymization setting can be used to anonymize the event source. For example, the event currently lists redev-env as the creator organization. If we wish to share this event without revealing the original organization, we can anonymize it. The tool will replace it with the organization defined in the anonymized_org parameter, in this case, simply named anonymized. If this organization does not already exist in the MISP instance, it will be automatically created by TINTED. We can also choose whether to remove the anonymized event from the local MISP instance, using the remove_anonymization_duplicate setting. In this demonstration, we will leave this set to false so that we can view the anonymized result. Now that the configuration is complete, we will demonstrate how to anonymize data within the event. Rather than anonymizing the entire event, we will tag specific attributes, for instance, the passport number. We will also tag an email address and an IP source address to be anonymized. Once complete, we publish the event to ZMQ. A new event is created. If we inspect it, we can see that the creator organization has been replaced by anonymized. The event information remains unchanged, but the attributes we tagged as sensitive, such as email source, email destination, and IP address, have been modified. These fields are now anonymized. Note that the attribute type, such as IP source, is no longer visible. This is because MISP does not support wildcards like asterisks for specific data types such as IPs or ports. As a result, the anonymized data is saved as a general text attribute, and its original type is included in the comment field. We can see here that the passport number is also anonymized. All of the information we marked as sensitive has now been anonymized. It is ready to be securely shared with other MISP instances. Now, we will demonstrate how to use the Threat Intelligence module in the CPR tool to securely share data. We will work from the CPR dashboard and use two user profiles: Alice, who shares the MISP event, and Bob, who receives it. This is the TINTED dashboard. On first access, you must configure your MISP instance and API key. You also need to set a threat level and analysis level that will be used in shared events. Then, generate an API key that enables access to TINTED via REST API. The passphrase shown here is the one registered in Keycloak. Once saved, you can test the MISP connection by clicking this button. From the Events tab, users can view events they have received or shared. To share an event securely, go to the Share tab, and select the MISP event to be shared. We will use this demo event as an example. The event info is shown here, and can also be encrypted if needed. All attributes included in the event are listed below. We will select specific attributes for sharing. For instance, we can choose to encrypt a domain and anonymize a hostname. Before sharing, we must specify the recipient. In this case, we will share the event with the user Bob. Once the recipient is selected, click Share. The event has now been uploaded. In the Events tab under Shared Information, we can see that this event has been shared with Bob. Now, if we switch to the MISP dashboard, the shared event appears here. Note that the event info is demo event, and it includes the tag Bob Sunrise Sharing, indicating the recipient. Clicking on the event shows its attributes. We can also see the sharing agreement attribute. The anonymized hostname is now replaced with asterisks. The encrypted domain appears as a string of encoded characters. Now we will log in to the TINTED dashboard as Bob. As Bob logs in, the shared demo event appears in the Information Received section. By clicking on it, Bob can view all shared attributes. The previously encrypted domain is now visible to the user. Let's now test access as another user, Susanna. When logged in as Susanna, no events are visible in the Events tab. This is expected, as the event was shared only with Bob and not Susanna. Now we will show how the CPR tool uses contextual health trends to support threat scoring. We begin by reviewing the environment file in the production.env configuration. Here, we can see the environment variables related to the health trends contextualization feature. To enable this functionality, set the variable Google Trends Monitoring to true. You must also define the time for the daily synchronization using Health Trends Sync Time. This setting ensures the system retrieves updated trend data at the specified time each day. You must specify the name of the file containing the search terms for Google Trends. In this example, it's configured here. You also need to add a valid Google API key to perform the search queries. Now we move to the logs generated in the TINTED container, which is the CPR Threat Intelligence module. We can see the system is checking periodically for health context updates. Once the scheduled time arrives, the trend data is retrieved from Google Trends. In this example, two keywords are being used: gripe, flu in Spanish, and COVID. Trend percentages are calculated, and the average trend score is generated. This trend information is then packaged into a new MISP event. If we now check the CPR dashboard, we can view this event on the MISP interface. Here is the new MISP event titled Sunrise CPR, Contextualization of Health Trends for Threat Score. In the event details, we can see the trend scores and the keywords used. The search terms are configured in the specified file. For each term, you must define the language and the geographical scope. In this case, the search is performed using the Spanish language. Finally, if we look at the Kafka container and check the tinted topic via Kafka consumer, we can see how the MISP event has been received by the CPR system. It will now be passed to the CPR risk assessment module.